coming, and I just wanted to go over a couple quick things. One is that there's a general discussion about WUI, and when we look at wildland urban interface, we try to define what that term means. We hear people talking about it. I hear people go like, what does WUI really represent? The strategy here is that we start seeing developments and homes and building things starting to encroach into what we would call the wildlands. And wildlands is really just the property that's more undisturbed, stuff with more volatility in terms of being able to be burned. And so as we move closer to that, we have to start getting careful about the interface between those wildlands and residential in the urban world. But we are moving back into that part where we have to also be more careful about the fact that it doesn't have to be that. If you remember the Santa Rosa fire, Santa Rosa was not part of WUI. We lost an entire community. The 2018 campfire was really 19,000 homes and buildings were lost. And that kind of a fire in 2018, the Camp Fire was considered the largest natural disaster in the world in 2018. So the strategy here is to look at how are we seeing the interface and the natural side of things burning, and we're going to try to do some things that will help us improve a little bit about that. A couple statistics. If you look at California in general, between about 1975 and really 1999, we saw about 141 million acres burned. Between 2000 and 2013, we saw 161 million acres burned. So if you look at that time cycle variation, really in 13 years, burned more property than really in the previous near 25 years. And so those are the kind of statistics we're actually worried about. We also know that the California fire season has been extended dramatically. In the last 30 years, the season is extended by 84 days. So that means nearly 3 months have been added to what we would call wildfire season. And as we're trying to start understanding wildfires, we realize that we have to be more careful about buildings in general. We see that the estimates are a 15% increase in wildfires in the next 7 years and a 30% increase in the next 25. So those are all statistics that really represent us as an industry. How long do we think buildings should last is a really important thing. So we're going to have a discussion today about materials, about how we put things together, and I think it should be a really fun exercise in how buildings succeed. My name is Mark Liberty. I'm with Hayward Lumber. I've been teaching building science and building physics for almost 40 years. And what we're really trying to do is give us an education about materials and how things are put together. And we're not an engineering group, we're really representing product mix. And my partner in this deal is Rudy. And Rudy Lockhart is another amazing individual in terms of the science and the physics of building. So Rudy, you want to tell them a little bit about you and what we're going to do?
Sure. Rudy Lockhart with Hayward Lumber Company. And I've been in the operations and sales portion of Hayward for also almost 40 years, and work in the central market, Santa Barbara County and San Luis Obispo County. And what I've been experiencing from the supply side is questions and concerns and misunderstanding about what is required in a home or what can be done in a home to make it more resilient. And so my sales team and myself have been fielding questions from customers from as bad as I just failed my framing inspection because I didn't use fire resilient material on my eaves, and it's a WUI area. I didn't see it on the plans anywhere. It's a little note on page 17. What do I do? And in many cases, they've had to tear off untreated materials to replace them with something that would conform to the WUI standard. So that's just one example of the challenges that we're facing out in the field. But more than that, there's a lot of confusion about what's required. And one of the reasons for that confusion is that each municipality has a slightly different interpretation of how WUI should be conformed or performed to. And so that's why we've asked the building officials to be here. We have Brian here from local Redwood City Fire, and we've invited him as well as any of you to participate and to give us input, because there's two things we don't want to do. One is spread any misinformation, and two is miss any important point. So we're all here to learn. This is an informal environment, so your participation in what we're doing is welcome. One of the things we try to do is not just talk at you for an hour, hour and a half, because most of us then start thinking about lunch or the job site or other things. So we've tried to make this, and I call it in the spirit of Cal Poly, is make it interactive learning. So we want to do things, we want to watch things, because that's the kind of people we are. And so what we did is create some ways for you to actually see how something performs. And so we're going to have fun with that today. So again, like Mark, I thank you for coming out and being part of what we're doing this morning.
how do these materials perform, and the challenges that we have to do, put buildings together as systems. We forget that it's not this product, it's this product plus all the other things that go with it, from inside of the building all the way to the outside, from the gypsum through the insulation, through the sheathing materials, through the weather protection layers, through the cladding materials. Now we have complexities in roof systems and how they're vented, how Title 24 interfaces with the way WUI matters. So we've got all these challenges that feel like a lot of information, a lot of assault of change. And sometimes we feel like, okay, that's enough. But actually, it's really about building better buildings. And we'll talk about how there's trade-offs here as well. That can I add this material, subtract that material, actually improve performance and maybe moderate cost, so it's not always about adding cost. And Rudy's got a little thing that I'm going to ask him to share about insurance. So as we start doing that, does it make sense to save energy by using thermal insulation and those details? That helps cause a return on investment. But yeah, Rudy, maybe you can share a little bit about the insurance side of things. That imagine that in terms of another area of cost implications as well.
Sure. Yeah, so especially for you builders and specifiers, architects, one of the challenges we're seeing is customers or clients coming in, homeowners off the street coming to us saying, I just got this letter in the mail from my insurance company, and they're saying that because of the fire zone I'm in, it's a high fire, extreme fire zone, whatever the situation, that particular insurance company is saying, we don't want to cover you anymore, it's too high of a risk. Or we're willing to cover you, but your premium is going to be doubling or tripling. And they're coming into us wide-eyed, say, what do I do? How do I sell my home if it's not insurable, right? How do I get a mortgage on a home that I can't get insurance for? And so there's challenges that homeowners today are encountering. And the reason we want to bring that up is because when we talk about alternative building methods or products, most of them may be more expensive than what you're currently doing, because most of us build to a standard of code or requirement, which frankly is the cheapest we're legally allowed to build a structure. And that's not all bad, because we all have budgets. But as we talk to you about a product that may be slightly more expensive, what I imagine would be going through many of your minds is that, well, that's just great, Rudy, because right now I'm already 5% over budget. Lumber didn't help with that, thank you. Well, please remember, we didn't set the price on that, we just move along, but we know it's been a contributor. We're struggling with budgets, right? And how do we make that work? Well, what I would like you thinking about as we talk about these products is, what is the actual cost to my client? Because if they're looking at a $1,200 a year premium going up to a $3,200 a month premium, that's never gonna go away. Most people are building their homes to last, how long? What?
80?
100 years.
100? Yeah, so imagine if I look at that, and I just mentioned to you earlier that the time frame cycle of increased risk is 30% in 25 years. When is the optimum time, or the only time really, to add thermal efficiency to the buildings, because the cost of energy sure isn't going down, and the risk of fire going up? When's the optimum time to do that? And we have to do it now. And the idea is that how do I take a product, like a house, and make that product perform better and have economic benefits to it? Because it's not about just cost add. Saving energy and reducing the risk and the insurance premiums, to me, what if we could do it nearly cost neutral? When should we do that? When should we start? And we got to do it now. And I think it's pretty important to make those connections. Now, Rudy, I'm going to ask if you'll go over here. If you notice over here on the side behind me, is what we thought was a pretty cool thing. The first time I saw this, I went and saw what Rudy had done. I said, you got to be kidding me, that's amazing. Right, so what we did is we said, how does this stuff work? And he's going to tell you a little bit about the decisions that got made and what we're going to do with kind of cooking some materials to see how they work. Because we can see it from a manufacturer says, here's what it does, but we're always kind of a little skeptical and say, I'd like to try it.
So once again, most of the solutions we try to bring to our customers originate at the sales counter. That's where it all happens, right? So we're sitting there talking with customers, and they have a challenge with WUI that they want to meet. We price out a bid several different ways for them. And so one of the questions was, okay, I understand this better. Does this stuff really work? Have you ever tried it? No, we just bought it and we sold it to you. They said it would work, right? The brochure looks good. And so, but we don't know. And so, to be honest with you, it can get a little bit boring selling 2x4s all day long for 40 years. So we start digging into stuff a little bit deeper and saying, I wonder what happens, right? So we started with maybe one, and then we got well, that was kind of amazing, or either good or bad, what happened. And from there it kind of grew. And so at some point, Mark and I are sitting in my barn and think, well, I wonder what this one would do. I wonder what that one would do. And out of that came, well, let's limit it to at least 5 options that would give people a good understanding and representation of building building materials. So what we have here, and we're going to get these things going as Mark talks to you, because we want to cook them for a while and give you a real world understanding of how this stuff performs. Now, this isn't scientific by any means. You're going to see me moving back and forth with the thermometer, and my goal is to attempt to keep these as uniform as possible in temperature. And if you were back here watching me, it's almost impossible because the breeze comes through, and this isn't a scientific test. These products are, the companies that make some of these products pay huge money to have these things tested in laboratories that are done scientifically, whether it's the ASTME 84 or whether it's getting a UL rating. There's flame spread ratings, and that is done in a controlled environment. This is not controlled at all. This is just having some fun and seeing real world, which is where you use the materials, what's going to happen, right? So the first one we have is WP4. It's a TNG pine. It's used as starter board most commonly, right? And it can be an 8-inch or 6-inch. It's not fire treated, and this is what's on my home, and more than likely, this is what's on your home. So if you were to go home, this is how you would have an example of how your home would perform were you to get exposure to fire. So we're going to cook just the general, what we would call the standard in practice for construction. We're going to see how that one performs. That's number one. Number two would be the same product, but we went through treating on it. So we went to Hoover and we said, we want to treat this product, which several of our locations stock, not all of them, but as you demand more of this, we will stock it in all of them. Hoover does a good job, it's clear, and it's available, and this is pine, and you're going to be able to see, does this stuff really work? How does it compare to an untreated? Is it worth the difference in cost? It's not a huge difference. Is it worth it? Maybe so. I'll let you decide for yourself. So fire treated, Hoover treated material, non-treated. Let me get these nice and cute and straight. Okay, so those are horizontal applications that would typically represent an eave of your home. An eave is a focal point for us because as heat comes up the face of your building, as your building is defending itself, it gets trapped under that eave, so we get a concentration of heat in that location. And that's why eaves are such an important part of your structure and a key part of the WUI defense system. So these are going directly over the flame because that's how they would be exposed in the real world. The next three examples would be in cladding. So in this case, we're going to say we have standard 1/2 inch, it could be 3/8, OSB or CDX, untreated, just regular old plywood. That's what you're putting on your shear of your homes you're probably building today, and over the top of that would be some type of cladding. What we're going to use for our experiment is just hardy board, standard hardy. So you might have stucco over it, you might have hardy. This particular assembly meets WUI requirements in, I believe, all markets. So you would have a resilient material on the face, and then you would have standard untreated plywood behind it. We'll see how that one performs when we put it over the heat, but again, you have the defense of a non-combustible product over combustible in this case. So now we're saying we want to get a little bit better. So we're going to do the same thing, but we're going to take that same CDX material, it's a structural member, and we're going to fire treat it. There's slight differences in the structural rating of the panel, but it does meet, most engineers can make it meet your shear requirements. So now you have an opportunity to solve two problems with one assembly. You're going around the home one time, and you're solving a seismic challenge, and you could be solving a fire challenge. I'll let you decide after you see it. So this would be, again, a Hoover product that's fire treated, and it's going to go behind our cladding, which would be stucco or hardy or any of those that you choose to use. We're just going to watch and see what happens there. And then the final one would be an LP product, which is, again, it's a fire resilient material. It has a coating on it. This coating creates the defensive qualities of this product. The OSB itself is not fire treated because OSB cannot be fire treated. You can fire treat plywood, but not the OSB. So what's been done on this product is they've coated the top of it to give it the defense. So once again, we're going to see how, in a cladding situation, this also would meet your shear requirements. So you have structural and you have fire resilience. That's going to go behind our hardy siding, and we're going to see how it performs. So you all on board with that?
Great. Thank you, Rudy. So the next thing we're going to talk a little bit about is about structures. And when I look at building assemblies, I look at the vertical wall, and I'm going to call that our wall system. And I mentioned to you what the wall system comprises of. And I look at walls that also include windows, because I think that's an important part. We're going to show you what happens when I consider the fact that the importance of a window under WUI is that we have to now, if you're in a WUI zone, you need to go to tempered glass. One of the panes need to be tempered. So if you're, of course, closer than 18 inches to the floor, that inside tempering pane. If you're on the outside pane, would be then a tempered option. We're going to demonstrate for you a little bit later the difference between annealed glass, basic glass, and a tempered glass. I think it's important, but it's also part of the assembly. So now we have to look at the assembly in general, and that's really comprised of that wall system. But what happens when I take my wall system, gypsum, framing, insulation, and covering, and I go like this with it? Now it becomes a roof system. So in the roof systems, if we look at that, say, well, now what is that comprised of? In Title 24, are we seeing people move to push insulation up to the roof? So Title 24 says no more ducts in attics or unconditioned space. So now we're changing the boundary of that. We're also realizing that we vented attics before. When we vented attics, what was the reason we vented attics? What was the intention for the last 60 years that we vent attics? Bueno, to get rid of what? A couple things. Moisture and heat. So the premise was that if you ventilate the attic with hot outdoor air, it should just cool the attic down, right? So we realized that that actually doesn't perform all that well. We lose about maybe 10 to 30 degrees, basically, depending on the day, in terms of scrubbing heat off the roof, and not a significant play. The biggest risk to shingle life is the color of the shingle, not necessarily the temperature underneath it. So as I've got lifestyle within the building generating moisture, it tends to get up into the attic space. Now what's my risk? My risk is that moisture could come inside in contact with the roof decking and then maybe condense. If I could scrub that away with outdoor air, that would make the ventilation beneficial. Now we're looking at putting the insulation against the roof, and now what happens with the moisture? If it goes up, goes through the insulation, and condenses on the roof deck, am I at greater risk? And I think those are things that we have to be really careful of. So we're watching these technologies change in the face of thermal insulation and fire. I want you to remember something about fire and ventilated attics. When the firefighters I just worked at a conference recently, and the guys were there, and he said, we've watched embers fly in excess of 2 miles. Some of the flying embers in the fire can be the size of baseballs and larger. So that's impact issues, as well as the potential for the sparks and the embers to get up through a soffit into the attic space and ignite. Can also, in some cases, wedge itself in behind a piece of wood and create a fire that would exist. So we're trying to be really watchful of that. Yesterday in Salinas, the fire marshal there told us that they have seen under infrared cameras a 5-mile distance in which embers can fly. So that means we have to make sure our buildings have a resilience so they can stand up to the assault of the potential for fire and still be resilient. And I want to make sure that my house has got some resilience. Remember when we talk about fire issues, and what Rudy's dealing with here is, I want to be able to get out. So the idea is that some of these products can give you 15 minutes, maybe 30 minutes longer if the fire is difficult. So the challenge is maybe getting the firefighters enough time to get in and maybe help save a structure. So there's the difference. If the structure is gone, they really are at greater risk to go in and try to fight it. So I'm trying to give them a little bit of resilience.
Mark?
That's the strategy. I think we have a problem.
Sorry, Mark, I think we have a problem here.
Yeah.
So, okay, so you can see now, how long have we been going here? About 4 to 5 minutes?
Yeah.
And we already have the non-treated pine is supporting flame and fire on its own. I can turn the gas off and you'll see that it's on fire, right? And since we didn't get a fire permit here and we have the officials here, we're gonna go ahead and put this out because that was not our goal. And you can see it's burning on its own. Not a big surprise, right? Because all of us have had a campfire and you put pine in there and it burns pretty quickly. So it's not a big surprise, but it is a good illustration of, once again, this is on my house and probably yours. So that's the amount of defense you have in the current structure. So we'll put those in water to make sure we don't have any problems. And now that we have a burner available, we want to do something else, because rock wool is a product that these guys have been bragging about to no end. Because they say you can put it right on a flame, it won't burn, it has all kinds of water resistant qualities and everything else. They say, yeah, you guys are just salespeople. How about you put your money where your mouth is? So we're gonna put that on there, and I wanna see what's gonna happen, but I don't wanna just see if that burns or not. I wanna see, you got any money on you? You're bragging about this stuff. Come up, give me something here to put on there. Make it big enough that it's going to matter if it fails. Oh, I like it. That'll work. All right, well, I got a $50 bill. He's got his own confidence in his product that he says you can put this on top of there, a piece of paper on top of that insulation, and we're going to see what happens. So I'll get this one going again. We're cooking these other ones, and you'll see again, it's with the breeze, it's really hard to keep them the same, so I'm doing my best to make it a fair presentation.
Yeah, and when Rudy will show you some other piece of this, but remember, you're going to see that the edges, so when you put up your sheathing, your shear, how much gapping are you supposed to provide in the shear? On the OSB and plywood, how much? What kind of gap are you supposed to provide? 1/8 of an inch. So 1/8 of an inch is what you're supposed to put in the panel. So the idea is that can anything go through that material? We'll talk a little bit about that in length. The next thing I'd like to go through with you is really looking at wall systems. And we're going to do this to show you that if I look at everything that goes into with a wall system, you'll see conventional OSB sheathing. This is an example of using fiberglass or gypsum board over the top of it. It's a fiberglass facing, middle side core, and conventional gypsum at 5/8. So if I would imagine putting sheathing all around the building for shear and then having to go back and put gypsum on top of it, that's a labor challenge that we would have there. How could I look at maybe another option to save the time of going around twice? You can see that the importance, and we want to make sure we remember that. In the spring, we did a workshop here that talked a little bit about managing water. The biggest financial risk to our industry is the mismanagement of water. Litigation against flashing details, water intrusion, mold growth, and building assemblies is substantial. Currently, right now in Florida, state of Florida, there's over $2 billion in litigation for water intrusion in buildings, and in Philadelphia, it's nearly $500 million. So we look at the challenge of that. We still need to do the important things. Put on weather barriers, put on flashing, flash our windows, use proper sealants, use rain screens to make sure that the buildings are fairly robust. I use a term called resiliency. And what we're trying to do is to provide resiliency in buildings. Resilience to fire potential, resilience to storms and wind, and resilience to the issues of thermal performance and water. So we want to make sure you'll see that here. The other thing we added was this product called Rockwool on the exterior. And I think Rudy was giving the Rockwool guy a little bit of flack, but when you think about a product, it's been around for in excess of 50 years. It's actually been made out of basalt or just rock. And so they melt the rock into a liquid and they create a fiber out of it by spinning the fiber. Then they were able to put it together and build an insulation material. That's called Comfort Board 80. It's got an insulation value of about 4 for 1 inch. But it can take about 2,200 degrees on the face of it. It's hydrophobic, so water would run straight through it and there's no organics in it to fail. It also has some tremendous sound capabilities. So if I was looking at what would I use on the outside of a building, I might say, so what are the additional benefits I might get out of putting insulation on the exterior? If I use extruded polystyrene or something like expanded polystyrene, those are maybe fire supportive. Here's a product that would give me fire, sound, thermal insulation at the same time and be hydrophobic. So here's an example of putting exterior insulation on. How do I build a building with incredible thermal performance and resilience to the cost of energy, at the same time maybe making it more durable? And that was the point I was making about it. You'll also notice that on top of the weather barrier, we use something called a rain screen. Here we showed that a rain screen, which is about 5 millimeters, right in a range of 3/16, and that went on the wall, and then the cladding, the clear hardwood cedar went over the top, allowing me to have good drainage, not enough space to support airflow, but enough space to support improved drainage. So this overall assembly, you can see, is really designed to be weather efficient, thermally efficient, and also fire resistive. The little tip I'll just give you is when Rudy built this with the insulation on the outside, he put in a wood buck to bring the insulation out a little bit so that it would then line up with all my cladding systems. And so, well, you push the window out just a little bit because I don't want to set the window on insulation. I need something rigid and firm. So you'll just be able to see this little detail has now been pulled out. The insulation comes up clean. Now my trim on the outside goes over the top. I'm going to then rotate this around. I'm going to ask Rudy, while he's still looking at that, I'm going to keep an eye on it.
Oh, looks like we have a second failure here. So in this case, remember, this was a WUI compliant assembly, and so we had hardy cladding with a standard CDX behind it. And you can see that it's currently supporting flame. Now, in fairness, it's the edge of the material that's burning, right? But in real application, real world, as Mark said, almost all building materials need to be sized for spacing, or are sized for spacing, I should say, which means you leave gaps, which means a fire that's pushing against your structure is going to be finding those nooks and crevices. And what then becomes important is not what does it look like, but does it support flame? Is it encouraging and is it growing the problem, or is it just defending the space? And so once again, our goal here isn't to make fires, it's to show how performance is. So I'm gonna go ahead and turn this one off, and we're gonna assume that at this point, it's done its job. This is a WUI conforming assembly, but it's the minimum. So that's what code compliance will get you, is something in between doing what we did for the last 150 years and what we're currently doing and or could be doing. So this one's done.
Thanks, Rudy. So you can see the idea there is the strategy was to give me a protection of time. Did the Hardy on that face of that give me extra time than it did on the wood side? And that's that idea about 15 minutes. And so if you did that assembly, you would perform the right duty of giving me a little bit of a resilience. The challenge really ends up being is how do I look at the ability for it to withstand a little bit more? If I had a challenge and an opportunity, we talked about embers, and Rudy's going to come over here and share a little bit about trusses and roof assemblies. We talked about thermal insulation and building assemblies, but if we take a look at what we've really learned a lot about this flying ember thing, it's where we're going to talk about what happened and what the invention of an innovative product really kind of looks like.
So once again, we're not specifiers. What we're trying to do here today is show you options and alternatives that you have. When you see an assembly or a product that is intriguing to you or you feel confident in, we encourage you to take that back to your designer and have them incorporate that in your structure so that you know it's accomplishing the goal. So what we attempted to do here is show common overhang or eave scenarios. Remember, we talked about that being one of the most vulnerable points of a structure. Decks and eaves are where you have your exposure, and so what we did is we started at the top, which what we would consider the ideal situation for an eave detail. That would be a boxed eave. When we build them in our truss plant, we can put this understack on there if you want, so you don't have to. If that wasn't done, you can scab a 2x4 along the tail of either a cut and stack rafter or a truss. In that case, we have Hardy material on the lid. And then we have a Vulcan vent, that's a fusible vent, that's getting us fresh air into this cavity, or if it's available with your seismic requirements, you can either use vented blocks or screen blocks. If it's allowable, we have there we go. That's non-vented Hardy, that's correct. The old Hardy that we used to use, unfortunately, may not meet WUI in your area, so in fact, this may not even be available anymore. So what we're suggesting you consider would be a non-vented soffit material with a Vulcan fire resilient vent. So what we've done now is we have a 2-inch fascia, and what WUI is prescribing is material that's a nominal 2-inch or greater is exposable without being fire treated in virtually all municipalities. So we have a fascia that's 2-inch nominal or more, we have fire resilient lid, and we have a Vulcan vent. So the area above this assembly is not getting the fire exposure because we're stopping our heat, our embers, our sparks are all stopping here and rolling out. Again, that hot air coming up is going to concentrate here, but we've seen the defensibility of these products. This does not have to be fire treated. None of these members up here have to be fire treated when the lid is. That's assembly one. A boxed lid, the many advantages, it keeps your eaves and your home cleaner because you don't get cobwebs and spiders and dirt and debris in here. It makes a much cleaner structure, but that's getting into aesthetics, not fire treating. The next option for you, which would be probably the most common, is when we're using the PyroGuard fire-treated material, which this is here, in a 1x6 for a 24-inch on center assembly, is very common. We have 2-inch nominal, so non-fire treated fascia. We have fire treated on our overhang, and then we transition to a non-fire treated sheathing beyond our blocking. At this point, this is where your designer needs to come in, because in many assemblies, depending on the shear transfer requirements between your wall assembly and your trusses, you may be able to put a Vulcan E-vent in. 1 out of every 5 bays often is what we see, or 4 bays. Some engineers will say, nope, I want solid blocking. Then your only choice is to put vent blocking in and then put a Vulcan vent block in. It's a little bit more time consuming and a lot less air movement. In many cases now, as Mark said, we're starting to see attics that are non-vented at all. And in that case, we can just go with solid blocking in this situation. The attic is taking care of itself. The eave now has fire-treated material, 2-inch nominal, 2-inch nominal. We're in good shape. We can handle the fire load. The other alternative now is we want to go more than 24 inches because we have 3-inch or 4-inch tails that are 36 or 48-inch on center. Well, the 1x won't span that far. In that situation, we're going to go to a 2x6 decking. And with the 2x6 decking, again, we have 2-inch nominal. It doesn't have to be fire treated to meet WUI requirements. However, that is an option that we would encourage you to give your client to say, would you like to order this material fire treated instead of non? You're getting to see for yourself the difference. Even though this has a longer burn through period than the 1 inch, it doesn't mean it won't catch on fire. The quality is that it's going to take longer to burn through and collapse or create the danger for the occupant or somebody trying to defend that structure. So in this case, we have 2 inch nominal, no fire treated at all, but it does meet WUI. The additional challenge of going with the 2 inch decking is that you have to drop those tails. So if it's a truss situation, you have to be careful. We need to be aware when we're designing your trusses that you want to drop the tail, because if we do a 2x4 top cord, you may not have enough strength in that tail, depending how long it is and what kind of roofing material, to support that. So sometimes we find this detail causes us to kick the top cord up to a 2x6 instead of 2x4. Then you can notch it down so that your roof planes out correctly.
When you remember that what Rudy said, if you looked at this as just a piece of sheathing like we've already demonstrated, you're going to look at how you're cladding on the outside, how your fire protection is still going to be here to protect the wall system, so as that comes up. So I think it's a really good way of looking at that and saying how well, as Rudy mentioned, when the fire comes up, it's really assaulting that building up under those soffits. Is there anything you can do? This is pretty good strategy to give us those materials. Imagine if I had Hardy here with the Vulcan vent, Hardy here. That's a lot more robust assembly. Now we also look at stucco. Stucco's pretty resilient as well. If I've got a couple of conventional stucco on the cladding here, that helps to protect that assembly as well.
Same situation here. Where allowed, you can put a Vulcan vent. Where it's not allowed because of structural and or you have a conditioned attic space, you don't need to use the Vulcan vent, you go solid blocking. Okay?
Thanks, Rudy.
Yep, thank you. Let me get back on my flames here and see how we're doing.
Yeah,
for
I was trying to keep
uniformity.
an eye on that, but you're much better. I can feel the heat though. I can feel the heat. So the next thing I wanted to demonstrate was one other assembly that we all have to remember. Please, yeah.
The box Eave, if you insulated that box Eave section, do you have to have the Vulcan vent in there?
Well, it depends. If you intend it to be a ventilated cavity, then you'd have to have the Vulcan vent there. It depends on what you insulate it with. You could put something like rock wool into the cavity, try to provide this, but that might be some redundancy, still would be okay. If you're going to consider this to be a non-vented attic space, then the game changes a little bit. You wouldn't necessarily do that. People are concerned about this when you have boxed eaves. They think you have to vent the eaves because they think there's a problem there. Remember that air does not travel horizontally. So we have this misconception if you put gable end vents in that the air is going back and forth, that you vent flat roofs. Flat roofs don't vent either. So if you look at what I'm trying to accomplish here, how do I make sure that that's free from moisture intrusion? By isolating it a little bit, it tends to do a pretty good job. Remember, we're sending you wood, and if you're using KD lumber, that starts out at about 18% moisture content. Wood can take on a little bit of water, give it back up. It can go all the way to 26% moisture content before it's fiber saturation. So you've got a little resilience there. It'll expand and move around a little bit, but that's a pretty good strategy if you're looking at that. As soon as you move to these open eaves, you got to change the game a little bit in terms of materials. We'll show you a little bit more about the treated plywoods, but that might be your choice. Good question. Anybody else? So the last thing about the assemblies we wanted to talk about was about decks. You know, and if we look at decks, I was at the conference I was at, the fellow that was doing the workshop, he had been a hotshot crews for years, and he had said, showed us a little video, and the video was a community where there was a little group of housing, road in front, there was a backyard, it went up a slope to the back to the next row of houses. And they had showed a picture of somebody's Ring camera. They videotaped this and shared the camera video. A fire started in the backyard of the houses that were in this area. It went across the back and got the fence. The fence then lit the hillside up. It ran up and got to the underside of the deck, lit the deck on fire. There were 3 houses in burn in 7 minutes. So that was a remarkable speed at which the fire traveled. And he said many of us know how fast it goes, but with a little bit of wind, it's quite amazing what happens there. So let's take a look at the 3 deck assemblies and options. This is a treated deck for decay and rodents and things, or insects. So you can see this deck has been treated. If you look at the edge, you can see the depth at which the penetration of the treatment goes. We know that if we cut that, what do I have to do with the cut? I got to reseal it, so I got to reseal the cut. If I've got this close enough to grade where I'm a little bit worried about that, that might be a choice. And you realize that if we treat for decay and insects, we can no longer treat for fire. It can't be both. So you have to pick. Do I want fire-treated floor joists and rim boards, or do I want it to be resilient? In this application, if you said, I'm kind of concerned about the rot and decay, Here you can see what they did is build a skirt down to reduce the potential for the embers to come up underneath. This is just a little skirt, and they used hardy board on the bottom so I could be closer to the ground, still prevent the embers from getting up underneath and maybe igniting the deck from the bottom side. So there's a way of strategizing that. Let's say though that we're up a little higher, maybe a cantilevered floor or a space where the fire can come up from underneath. Now we can look at something like this. It's a fire-treated dimensional lumber, and that might be the right approach there to say, I need to protect that. When you look at the deck coverings or the finished materials on the tops, we look at things like AZEK and TimberTech and the other
Mark,
products that you see
sorry
around
to interrupt
here.
you there. Sorry to interrupt you, but I do want to bring to your attention that we have our next failure here. And in this situation, we have the surface of the material is probably well protected, but you can see that the edge of the material is beginning to ignite. So it's getting really, really hot, and at some point it'll flash. So you can see that the flame block in this case has begun to burn on the edges. So we're going to turn that one off, and we're down to 2. But again, and when we're done, we'll turn these over so you can actually see how each of them have performed. And you got to remember, this has been going for what, 30 minutes now with at around 400, 450 degrees Fahrenheit with a flame right on it, compared to pine that went for about what, 5 minutes and was already on fire. So, thanks, sorry.
Thank you. So, we'll go back to the deck surfaces. So if you can look at these kind of decks, these are engineered surface and composite decking. They are WUI rated, and so that decking can be on top of this assembly. So if I've got treated for rot and decay, I've protected the underside from getting a fire, I can put these materials that are also WUI rated. If I look at this one, which is Firex treated dimensional lumber, you notice that the product is fire treated all the way through. You do not have to retreat the cut ends. Once you cut it, it still goes all the way through the product. You're in good shape there. So now I can put on top of it. I can use a solid decking here, and this is kind of like Ipe, and then I can also look at solid 2-inch dimensional redwood or cedar, still would qualify for a fire resistance from coming up underneath. So you know that this would have a tendency to char, still potentially get a little bit of burn to it, but it wouldn't burn through. One of the things about decking, remember, is that potentially is our egress in and out of the building. So if I want to make sure that these decks are ready for that, should I need to get out, there's an opportunity there. If you just throw me behind you, there's that roll, that black roll. Yep. So how many of you guys have started to place? This is a fairly new approach, but it's a remarkably good idea. I think a lot of it got taken over on social media as a strategy, but we're really watching how these deck joists are starting to be. If you ever pull a deck apart, you'll see the decay really ends up happening at the joints where the deck board meets the building, and there's debris and organics fall between there, and you'll get rot in those locations. So we're seeing companies come up. This happens to be a product by Protector Wrap called Deck Joist Tape. And we're really just taking an acrylic-based tape that goes over the top of the deck board, and then your material gets put on top of that. So this is a way of helping to reduce some maybe decay on the board itself and still protect the assembly. So and the last topic we'll show you in terms of materials goes is this one here. We've got the folks over there from Fortress, but this is a steel decking material. Now imagine something where you've got steel joists, everything is made out of steel. I can still then put this type of decking on top of it. So I've got a conventional type decking, I've got a remarkable level of steel and tenacity. Being a wood-based company, we still are pretty okay with the steel thing. Actually, we're really cool with it. Fortress guys are amazing. And the opportunity is there, you could put a deck like this. If you look at resilience, we'd say probably our concern might be if this was too close to coastal, we'd have to be careful about things like rust or something else. So taking a look at what your deck, what the application is, what the material's like, that all matters in terms of your application. But I like buildings that are more resilient to water intrusion, resilient to fire, and resilient to the increase in the cost of energy. So the last couple of comments here, and I'm going to borrow the guys from Rockwell, has a little display over here, and just show you a little bit about what I'm thinking about in terms of insulation. So if the product can take about 2200 degrees, imagine if I've got my cladding on the outside, I've got sheathing material and there's a little fissure between the sheathing, I could then look at putting the Rockwell insulation on the inside of cavity. And so the cavity bats are pretty cool. One thing I really like about it is that they're, I'm gonna borrow that from you if you don't mind. So I wanted you to look at something else. This stuff is pretty cool. So here's the bats. And the bats have a similar R value to fiberglass, but they're a little more tenacious. I like if you're trying to cut around an electrical box, I can actually take this little saw, cut that like this, and now I've got an easier way of getting to those bats. If you look at fiberglass bats, they're really tough to move around the bat, split the bats. I can actually cut that assembly and cut out the back of it for a wire. So I can go like this, cut that out, and really allow that to fit in for the cavity. That's cool for the bat stuff. On the exterior of the building, this is called Comfort Board 180, and this product was on the exterior, and if I take a little saw like this, I can put it on the outside, and I can just cut the product like that. It's a really clean cut. It's incredibly durable stuff. And like I said, it's also hydrophobic. This felt like 110. Was it 110?
That is,
Oh, yeah, 110. So 110 is the denser product. So they have 80, they have 110. 110 is a much denser board. It's almost impossible to compress. It's used oftentimes on roof decks. And you can get it up to 5 inches thick, I believe. 6 inches thick to act as thermal insulation. So these are ways of adding a level of robustness to the building, or a level of resilience that's improved. Over here, he's got a little torch. Is your propane?
Yep.
Yeah, it's running. So that's been running since they got here. That's a butane torch, and blasting against that product, like I said, 2,200 degrees, and
Yeah,
still provides some
But
benefit.
he doesn't
to
have
it.
$50 on his torch.
No, that's exactly right. I'm surprised he didn't hang one down just to burn that thing up like that. So I guess those are the kind of ideas. We also wanted to let you know that the Vulcan vent guys, I'm not sure if they're capable of burning anything now, but would you like to bring that up? So I wanted to have him bring up a material there, and he's going to do it right over here. So if everybody wants to turn around and take a look at this, it's kind of interesting to see what does that product actually do. It sounds magic, right? I've got a vent that goes in there, and somehow when we put a little fire to it, it has the potential to close up.
go ahead and move that a little bit.
Won't waste too much time with it, but this is on unnatural gas. We're also going to do some burning later. But so the basis of the Vulcan vent, it's a 3-part vent. So on the back side is to stop your flying embers. It's got a 14 mesh. On the inside is an aluminum honeycomb with an intumescent coating, and the front side is a pest abatement barrier. So the idea is about 90% of homes seem to catch on fire from flying embers, is the number they're giving out now. So the mesh will stop that flying ember from getting in your house all the time, every time. That does not impact the intumescent coating in the middle. When a firewall actually approaches your house, the inside of the vent will swell up, shutting the complete vent off so no penetration can get into your attic, your crawl space, your soffits, anything like that. And then the pest abatement just stops your rodents and stuff like that. So
Thank you.
thank you, Mark.
Your bet. And so the idea really ends up being, of course, if you get to a situation where the fire is intense enough to block off the vent and close it, that would be what you would replace. So you would replace the vents. But it's pretty nice to have that. It's also retrofittable if you had to retrofit to an existing product or an existing house. So they have an opportunity to do that a little bit later as well. The guys from Hardy are also over there. We've got TimberTech Fiberon. We've got the guys from Fortress and Rockwell over here that I'd really love to kind of show you how their systems work. So we'd like you to just stick around for a minute to see that. But
And we have some glass to experiment too.
yeah, glass too. So thank you, Rudy, for that. So if you guys wouldn't mind and just step behind this this level of lumber here, what I'm going to do is I'm going to show you something. Thanks, Rudy. I'm going to show you a little example here of one of these pieces is annealed glass. One of these pieces is tempered glass. So I'm going to need to have a Hayward employee just for risk, and I think that the first person I thought of about having somebody with that risk would be Mr. Villar. So Dave, why don't you come up here? That's what you get for standing close enough. And so I'm going to have David come up. He's going to do a little, help us with this experiment. So you want to put that thing on?
So one of the reasons that we would want to be playing around with glass is because a critical part of the WUI requirements is that at least one of the 2 layers of glass in an insulated glass unit is tempered. And you might wonder, why is that? Is it just more cost? Is it more regulation? What's the reason for that? Well, you can imagine, as he's doing this little experiment here, you give your recliner inside your big picture window of your home, and Brian could tell us, when you're in a wildland fire, you can have embers and debris, chunks of wood the size of a baseball flying. We were saying 2 miles, but one of the officials told us they go as much as 5 miles because of that storm that's being created by the fire. That this debris is just flying ahead of the fire, and so this stuff is pelting your house. And the challenge is, you can do all the defensible measures you want, but if you break the windows of your home and this chunk of charred wood that's burning lands on your favorite recliner, you're kind of SOL, because what are you going to do, right? It's going to start the entire inside of your home on fire, even though it's defensible from the outside. So one of the components of WUI is that at least one layer of the 2 layers of glass minimum is tempered material. And so once again, why? Well, we're going to play with it and find out.
What I'm going to ask David to do is take this hammer, and at first I just want him to let it go and let gravity go in each direction to see how they're going to go. As he progresses, we're going to see if he can get one of those.
Do you know which one is tempered?
He doesn't know.
I don't know.
Do you know which one? No.
Because there's no marking on it.
Okay,
Right.
we don't want you to know.
So go ahead and let one go left and one go right. All right, now let's see what you're made out of. A little more effort.
Come on, put a little more behind there. Oh,
We just found the annealed glass. Try
that
the
didn't
other
take
side.
much. Oh, put some muscle behind it. What? What?
I'm 58 years old, okay?
Oh, 58. So that's about
Oh,
one
my
more
goodness.
time.
One more time. See if you can do it. Wow.
That's pretty impressive. About 5 times the ability for glass to maintain that kind of impact resistance. Look what happens we have annealed glass. It becomes shards. So the idea that Rudy and I have done 6 of these, this is our 6th one. We've had everybody possible come here and try to break this piece, and it's not broken. We've had people come in here yesterday we had one of the employees with Hayward, and she's always having to work with the finance department. So we told her that one of the people didn't turn in their paperwork. We thought that would light her right up, and she really gave it a slam and still wasn't able to break it. Do you want to try?
No, I don't think I can do it. Muscles like that can't do it. I can't do. But what can you tell us a little bit about Cardinal Glass and what that process is like?
Yeah, Cardinal Glass is pretty amazing. It's a company. It's the largest company in the United States, actually in the world, that does tempering. They have about 40 different plants around the U.S. that does tempered glass. And one of my requests was, can you get me some tempered glass? And he said, I'm going to have to run individual pieces because you can't cut tempered glass, right? So the company is quite amazing. They're the largest manufacturer of insulated and high-performance glass. They have about 15 different versions of different high-performance glass. I'm building a house right now with triple glazed glass. The R value of the glazing is equivalent to a 2x4 wall in a 2x4 assembly. So that's pretty impressive to have that kind of glass. Cardinal is really remarkable in terms of what they have. They even have a glass on the outside that's got a coating that you don't have to wash it as often. Something about the way it charges particles is rain rinses it off. So we wanted to make sure we thanked them for such a generous supplying of glass. What's really funny about it is when we ordered glass, I ordered 6 pieces because I figured we're going to break them at every event. This piece has been at every event, smacked like we did, and we haven't broken one yet. So I thought that was pretty amazing. We had no idea that would be the case.
Mark, I'd like to hear a little bit from Brian. He's been so patient letting us burn and do experiments in his city without complaining. And one of our focuses here as we began was on the building itself, because there's so little information available for people. There's a little bit more about defensible space, which ultimately, if you're going to do anything, is the more important. But Brian, would you be willing to just give us a little bit of an update on what your city's doing and how we can better protect our homes?
Brian Pizzaminti, Redwood City Fire Department. I'm a fire prevention officer.
Brian, could I interrupt you for one moment? I'm sorry, I forgot. I'm going to turn these flames off right now because I want these to cool down while Brian's finishing up with us, and that way you can come and look at them and nobody will get hurt. So I'm going to go ahead and turn all these off, and that's why. So we'll have something that you can play around with. Sorry.
Happy to be here today. Thanks everybody for coming out. Fire department's goal, to protect life, property, and the environment. Life always comes first, then your structure will come second. Our first defensible mechanism that we have to protect your home is defensible space. Just some quick numbers. We want that 100-foot distance of non-combustible materials. If you have trees with low limbs, we call that ladder feel. We want to remove those for the potential to get high up in the tree, and due to weather conditions, we start getting it, and it moves to the next, and then moves to the next, and then it grows. So defensible space is your first priority you could have on your structure. After that, once we go to the structure, then we start talking about your materials. The materials that are now being offered are non-combustible materials, and that is increasing the survivability rate of your structure. What that is also doing is allowing, when we have a big fire, all our resources are going there. Mutual aid's coming in. So having that, yes, we're working, but the amount of firefighters and personnel that are on the ground, we may be behind in forecasting to getting resources to your structure. So by doing some of these things is again adding more time, so we could get there with extinguishing methods and to protect your structure.
Defensible space.
Defensible space. Thank you. I'd like to just start off by having a big address on your location. Yes, we could follow the smoke, but in the events we're going to a cardiac arrest, we can't see that. So I like address identification, get us to the right spot. Again, we want to get that 100 feet. Any grasses, they're less than 6 to 4 inches. So that way you're decreasing the spread and the rate of the fire. Our eaves protection and talking about some of our vents, those are now decreasing to size. You're allowed to have an 1/8 of an inch. This was a good demonstration over here. I was looking behind on the flame, and it was very difficult to see anything going through. So the things that are offered here today, I encourage us to build. And then also, back to defensible space, there's certain districts or geographical locations that the state fire marshal has designated very high severity danger zone. If you are located and live in those areas and plan on to build new construction, in the building code, chapter 7B, you're going to be required to use some of these materials in those. Does anybody have any questions?
I have a comment. I don't know if you noticed, but our $50 bill, it made it through our test. So we don't make any of this stuff at Hayward, but we supply it. And the vendor that made it had enough confidence that he would put a bill like that on there. So we're all done with this experiment. Yeah. Thank you.
He's really at about $600 now so far in all these events.
I love these
other
things.
People
They're
kicking
great.
Up hundreds, but this guy only left at 50 because he's lost it every single time. So it's pretty impressive. Anybody else have any questions for Brian? Well, if you don't mind, I'd like to thank Brian and the fire department here and the firefighters for what they do.
Thank you.
Thank you, Brian. If they see a house is on fire and it looks like it's at risk, they're probably not going to go in to fight it. They're really looking at their own protection as well.
You know, another recommendation is that you don't pick up a washer that's sitting on a 400-degree flame for an hour without gloves on.
I was pretty impressed
So
with
we
that.
learn something every day, don't
When
we?
I saw that winds come across your eyes, I go, that dude's he can take some pain. So that's another great lesson. Lastly, I just wanted to, of course, thank you for coming and realize that Hayward is a 103-year-old company. And one of the things that we do is create an idea that it's about family and about the things that we really care about our environment and our community. In all of our branches from Santa Barbara up through Redwood City here, we all care about that. We want to make sure that the people within this company are able to help you. If you wouldn't mind, everybody with Hayward, would you just raise your hand so you can see the people around you that are all represent the company and are really trying to learn. They came here today to learn. I myself working and Rudy are also concerned about sharing information that we think is important and making you see that we think we're a bit of a difference in terms of how that works. We'd also like to make sure if you take a chance to stop at some of the vendors, pick up some materials to do that. If there's also something that you'd like us to take a look at, a product you'd like us to consider, bring that in. Our goal is to make sure that we can help you with the things that might be necessary. If you said, I've heard about this, would you take a look at this? There is a product that you'll start seeing come into the marketplace as well, and it's called MgO. It's magnesium oxide, and this is an MgO product. You'll start seeing more of this kind of stuff come into play. And these are materials that are actually been around for a very long time. Insect resistant, structural, fire resistive, water resistive. So you'll see more of these things starting to come out as we can build actually wall systems and panels out of a product like this that has remarkable tenacity and durability. So keep an eye out for the fact that these things are coming into play as well.
It's not hot.
Oh, good, thank you. I was just saying with the hot glove thing, I was going to, boy, dude. So we wanted to show you a couple quick things about this. So this was a piece of Hardy that was on there for nearly, what, an hour? probably an hour at about, you figure an hour at about 400 degrees. So Rudy and I were quite amazed when we first did this experiment by his barn. It did involve just a little bit of wine, but when we were doing this, we took a look at this, and I never expected this to have that type of resilience. After it was sitting there on the burner, we thought, boy, for a product that's that thin and that capable, that was protecting a lot of the assemblies. You can also take a look at it that it did something else, and that's called fissuring. So as a product fissures, whether it's made out of gypsum, when they fire test, you saw a piece of gypsum I had up there, when they fire test gypsum, they'll take gypsum to a fire rating when it fails once the product burns through or creates a fissure. Once the fissure goes through, the flame can then leap through the product. So this is an example of Hardy's product, and I think it's pretty impressive. It also bakes out all the moisture that's left in the board, so it then does become a little more fragile. So if you look at it in terms of its ability to probably have resistance and remarkable fire retardancy, should that be under that exposure, if all you had to do is replace the siding, that wouldn't be too bad, would it? Be pretty amazing if it helped provide resilience. And again, against the backdrop of another product like we saw in the fire-treated assemblies. If you looked at this product and how this didn't even last for less than 5 minutes, that's the type of char it would have been through. But if you looked at this one here, this is the fire-rated Hoover product. Look at that material on the underside, but on the top side. But if you look at this in terms of the fire, if you look at a fire that you're burning in your campfire, you put a log in the fire, and when you see that, sometimes it doesn't burn all the way through. A little frustrating sometimes. But what it does, it creates a char. The char on the outside helps to protect the wood on the inside, which is pretty amazing. So that's the idea behind this fire treatment. You can see that this stuff allows the char to occur, somewhat protect the wood, but the other side of it, and providing some additional strength. We also noticed that when we looked at the fire-treated plywood, which took the entire burn time, you can see that this product really charred again. That's the idea, that the char creates a little bit of insulation, but the product is really quite durable and still provides some rigidity left in the structure of the product. So those are the kind of things we like, a little bit more additional resilience. Remember, we pushed all of these beyond their expectation. None of these were supposed to go that long, that far, so we think it's important to create redundancy. So we'd sure like to encourage you to do that. As you also looked at the last one, this was called Flame Block. This is by an LP product. And remember what Rudy said, you can't fire treat OSB, you can only fire treat plywood. So to make OSB work, there's a magnesium oxide type coating on the front side, and that's proprietary. And on the front side, you can see that it helped protect the OSB. As it fissures, then the fire could then go through and potentially consume the OSB. But those are the things that we can do to give us time, the opportunity to get to a fire, maybe save a structure, sure makes good sense. So those are the examples you can come up and take a look at. So we really do appreciate you guys coming, and we thank you for letting Hayward be part of your team and part of your process in terms of building buildings. And we want to thank all of you for making the time to come today. Are there anybody that has any additional questions that you'd like answered or anything else? Thank you.